Okay, good day. So I'm just going to quickly showcase how to do it in like mops. Circle. So I'm going to put down a circle quickly. I don't really care what I'm doing. Add the divisions. I'm going to add a noise quickly. Don't worry about this. Okay. So I'm just going to go like that quickly. Then I'm going to do a transform. Sorry. And in here, I'm also going to add an offset. So all I've done here is I made an alligator noise. And I'm going to drive this. I'm going to put down a copy to points here. And in here, I'm going to make a detail angle. So. And I'm just going to create some points so we don't need to worry about how I'm doing all this, because I don't expect you to know it just yet, how to do something like this in Vex. But all I'm doing here is I'm just making points in the center. Pardon. A vector here. Just in the center here. So, like that, we're going to see we've got 1,200 points. Give me a moment, please. Okay, apologies. And all I'm going to do is I'm going to make like a random rotation. And the way I can do that is I'm going to use the normal. So if we have a normal like that, we can adjust the rotation. Honestly though, it's probably better to showcase how to do an orientation, but that's a bit advanced. So okay, so well actually no, quickly. So when you're copying to points, the direction that it's going to take for the point versus what the incoming geometry is going to rely. It's going to first look for an orient, an orient attribute, which is a quaternion, a vector 4, if you will. If I can't find that, it will look for a normal and an up vector. So we can actually make a quaternion with those two, but for now we're just going to make a normal standard normal direction. So I'm going to say normal vector norm equals so, and then I'm going to set that normal quickly. So now you can see that I can actually set where the normal's facing here, like so. But it's still not quite what I wanted to do, so I'm going to say I want to do a one for the up vector. But for this one, I'm just going to say random. So you can do this in a multitude of ways, like so. And then I could do like a p scale for random, this sort of stuff. So float p scale, it's going to be random sort of thing, and I would just set the p scale to that. But I would also need to adjust this, so that's fit 01 between a channel float min, channel float max, like so. So now we get something like that. Okay. And now what we want to do is we want to just rotate that around. And all I'm going to do with that is I'm just going to probably either rotate this. That's actually pretty cool. Rotate it on like that. You can probably adjust the rotation here, but it's fine for now. Actually, I'm going to keep it like this. So I'm going to transform it in this after I copy the points, and I'm just going to transform it that way. So float. Oh wait, FF for subframe. Want to be a bit faster, so let's go times 5. That's where to put on that. Okay, those are my points that I'm going to be using. I can probably add even more. So let's say 300. So, and with the noise, what I can do for each point. So this is similar to how the copy stamp used to work. Not anymore. We don't use the copy stamp. So got this bad boy. And inside here, what I would do is I'm just going to put a null down, and I'm going to reference in that. In here, actually I don't need null, honestly. And in here, I want to set the offset. So I'm going to say channel V offset. Oops, sorry, so I'm going to say vector offset. You like that. I'm going to set this to be the offset of here, like so. We can offset like this, or we can offset like that. Honestly, it's probably going to be better to go along the z-axis. So let's go along the z-axis. And the way I can do that is I can bring in, I can make a random scale. So for here, I can go, I can just copy paste this bad boy. Inside here, I'm going to say offset. So, and I'm going to say min max 2. So it's going to go between -20 and 20. Let me just set that. So this one's going to be the offset. Don't worry about all these facts. This is just me making a point, like making 10 points and just adding all these random things. So this isn't part. You're already doing all this inside the nodes anyway. This is just me complicating it to hell. So I'm going to say offset equals, let's go offset equals set off.x, off.y, and off z, so that nothing actually changes, but I'm going to get in the offset from here. And in here, what I'm going to do is I'm going to say point, so float in off, which is point 1 set, and because we're going over each point, I just need to say 0. I'm just going to say plus in, like so. Now we get something like that. And if we want to change the scale of this, we would do an amplitude here. Okay. Cool. So let's add a trail node, and I'm going to trail it so I can compute the velocity. So now we get a velocity in here. Let's bring in our point. Actually, no, yep, that's correct. Let's bring in our point. Point. What's a pop map? I'm going to plug this into the first input. dive inside, scale at all points. So I'm going to see it something like that. Pretty cool, kind of, I guess. I'm going to set the pixels so it's a little nicer to see. Let's try and get rid of this jitter along here first. So I'm going to go to my perf. I'm going to see interpolate source forward. I'm going to keep it to match topology. It really does depend. Now we're seeing something a bit nicer. We're seeing it more or less along like that than anything else. Okay, now let's make a suction force. The way I like to do this is I'm going to make a line. So I'm going to make a line in here. Visualize it like that. I'm going to set it along the Z direction. I'm going to put it in the middle. Like so. And I'm just going to scatter a whole heap of points on it. And I'm going to also scale it down a lot. Okay, I'm going to plug it into the second input. Inside here, I'm going to make a pop. And in the data, in the inputs, I'm going to say second input is going to be the second context geometry, which is this one here. All right. Now, what I want to do is I want to basically, it's kind of complicated, but I basically want to suck it in first. So let's quickly figure out how to do that, which I believe is what we need to do is we need to make a point cloud. And the point cloud is basically going to take, so each point is going to try and find that second input. So I'm going to say PC open, which is that point cloud. I'm going to put in our position here. I'm going to put in our file, which is our second input. And I'm going to keep everything else the same, except I'm going to push this to about 1000. And then I'm going to say PC filter. And in here I want to get the position. And if I got that, then you're going to see that it's all going to be put into the middle, basically there, except for the starting points. But what I want to do is I want to basically say, I think it's subtract. I want to subtract this current position by this position here. And that, I think, should be what we want to do, if we're not. Is our velocity, maybe we wanted to add it to. Nope. Okay, give me a moment to quickly go back to my old notes. Okay, I was being an idiot. I don't want to put it into position, I want to put it into velocity. I want to subtract this by our current position. As you can see here, we're now getting a bit of a suction force. But let's say we want to have it, instead of just moving in perfectly like that, let's make a rotation. The way we do that is we do like a cross product between the two. And I will link in videos if you want to figure out what those are. And what we want to do is, beg your pardon, is we want to take a normalized version of this first. So normalize. This is going to go into the first cross product here. This one's going to go into a second normalize. And I'm going to go PC filter and I'm going to grab the normal. The normal I need to set. The normal is just going to be, so we don't have a normal yet, so I'm just going to do polyframe. Come on, where's my polyframe? There it is, over there. And instead of n here, I'm just going to place n into my tangent name. So, and you can see it's actually pointing along the line. Jumping inside here. We're not really seeing much happen here. So what we want to do here is we now want to add these two together. And we also actually want to set this to be n. And you can see it's actually rotating a little bit. Okay. So if we wanted it to follow the curve, basically, then we would do something a little different. We would basically take this one here and we would add that as well. So then it's actually going to follow the curve. But once it hits the end of the curve, it's just going to stop. So that's a one method we could use for that. But how about adding some noise? Well, we could do it a few ways. We could do like a noise sort of thing, or we could just add it to here. So I'm going to say AO noise. Plug this in here. I'm going to say 3D input. Yep. Not really seeing much going on, so let's boost that up to about 4. Now we're seeing it's following the noise very perfectly though. So we basically want to have this change over time. The way we can do that is we can say, hey, give me the either the time or the frame. So let's go with the time. I'm going to say vector, I'm going to say float to vector. And I'm going to put it in the Z axis. Now we can see we're getting something like this. This may or may not be what you want. I'm going to increase the frequency. Which is a little weird. And it's not really adjusting much. Another thing you can do is we can take in this positional here. This position data. We can add to that. So let's add. That's not right. Let's add. And we will get that happening anyway, basically. But we'll need to speed this one up as well. So let's go multiply constant. And let's increase by 12. Even then, that's a little bit too much. So I tend to use a turb noise for these sorts of things. Add that to there. And I want to say free noise. Yep. And I want to scale that. Right, I need to actually put in the position too. So the position will be here, and the offset will be here. So now we're getting something a little bit like that. And then we can just layer these noises together. Another thing we can do is, so I'm going to increase this to about 4. You can see it kind of working. It's not really nice though. Another thing we can do, instead of adding the noise to there, we can add the noise to point cloud. Which actually wouldn't do much because we've got a max radius of like 10. So if we set that to like 1, then we get something a bit like that, which honestly does look pretty cool. I'm also going to turn off this. I don't want that. Oops, no, I don't want this one. I don't want it to follow the curve. I just want it to go in. And you can see it's actually going right into the center. We can set it so it doesn't go into the center if we want it to. What I'm going to do here though is I'm just going to turn this down to like 1, increase this to about 4, no, increase this about, put it back down to 2, and I'm going to say sparse convolution, so it's going in both ways. And you would add a pop force here, which will probably be a better way of doing like noise. something like that. If you didn't want to have it in such a ball like method, you would turn down this. So let's turn this down to 0.1. You can see we're still getting that. If we wanted to have something more of like a fall off, we would basically have to do like a we would have to basically fall off the what's the word? The curve here. Also, if you wanted it to go a different direction, you would just negate either this, I believe, or the other one. So now it's going in another direction, which may or may not be what you want. Finally, what you would also want to do is, if you want to have a bit more of a fall off, so let's try and get a fall off going. So let's say a ramp parameter. Did I put my voice back on? I did. Let's put like a ramp parameter here. You can see it's kind of working. If we push this all the way down to black, then none of it should be working really. If we go the other way. Oh wait. What we want to do is we want to get a distance threshold. So we want to say the distance between we want to say, so this is we can just say that because this is a subtraction, we can say the length. So we can say length. So this is going to give us a length parameter. We need to fit range this. So we're going to say the negative, these two we're going to push up to the parameter. We're going to plug it into a spline ramp here, and then we're going to multiply that. So we chuck that in here, and we multiply it by a float, so that this is still a vector. So if we now go here like that, we can get like a fall off basically. If we increase the max radius, then it's going to go a bit closer to there. If we decrease it, then it will hopefully get closer. But that's basically how we do like a bit of a fall off for that. If I want to set like 0.5, and then just bring this down a little bit, maybe something like that. Then we can get that. And that's basically what a way to do that sort of thing. It's a very simple setup. It only took me 20 minutes. Hopefully that was helpful to somebody. You'd probably add more points and different waves, and you'd layer on, and you'd add noise, and you'd add color. So where you can do like a random color. So I'm just going to say random, just so that you can see what I'm doing. Random attribute color. That's just going to randomize the color. So we get a different color each time. Now you can see we're actually getting that random color there. We can also scale by take this, and we can say, hey, can we get like color on this as well? So I'm not gonna duplicate it. I'm gonna say channel ramp. Oops, sorry, I'm very used to making two. This is gonna be color. Plug it into the color node here, and inside here I'm going to set it. So let's just say red to blue, in a sense. And this is the way we can actually visualize where this fall off is also going, if you wanted it to be like that. So we can see that's the fall off there. This is going to affect the fall off in some degree, I hope. No, wait, I will probably need to actually plug that into there if I wanted to see the fall off properly of how that's working. So you can color that in a distinct way. I'm going to bet 0.5, and I'm actually going to make that a bit closer like so. Something like that. And we would then I would then just, instead of using by that ramp, I would actually just use this ramp here. And you would actually put this outside. So I'm going to jump back up here. I'm going to bring in the top import. Actually, I'm going to use top import fields because I like that a little bit better. Plug this in here. This is going to be a pop object. And then I'm just going to say particles. That's just going to give me the geometry. Inside here, I can do a point flop sort of thing. And I can do the exact same setup as I had up there. One other thing we could do is we could visualize the speed. And the way we do this, we say length. Plug this into a channel ramp, so a ramp parameter here, and then we'll do a fit range between the two, and we'll plug the source max up. So the source max will be where it's the fastest. So I'm going to set this to red so I can see where the red is coming in, and this one's going to be blue. And then what I like to do is I like to get the old flip fluid mesh, the fluid surface one, because it has a very nice visualize on it, for that ramp at least. And I like to paste it in there and just visualize it like that a bit. You can see some parts are moving faster than the others as well because of the noise that we applied earlier. It does look a little weird, honestly. Like some points are moving a lot faster than others. And we would add like a drag then, honestly. So, oops. So inside here, I would do a pop, drag, and escape. And I'm going to put this at 0.05 because this is quite, this can be quite devastating. Now that's staying on a little bit longer, but we can also just get rid of this here if we didn't need it, and we'd still get a very simple result. We just want to get that speed up, such. And there you go. I hope that was helpful, in some capacity. We could also scale it by how close it is to the center. So where we do that is we go PC open again, which is a point cloud. I'm going to push this to the position. The file is a second input here. That's the position. PC filter to get the current position. We would subtract between the two of these, get the length, make a new fit range between that and source max, and then we'd add a new ramp, so ramp parameter, so ramp 2, and then we just add to both of them, really. Inside here we would also scale this up, so let's promote that radius so we can get the exact same radius that this one was. This one was a radius of 1. So let's just put that to 1. And we can let's give the fringes so let's give the fringes some whiteness at least. So a bit of glow. So it's 0.2, 0.2, 0.2, like that. And over here I want to give it a bit of red. Or maybe just some orange. So let's dive inside here. Let's try and add something that'll kind of make it pop a little bit better. And then we can also add like a noise with this as well. So we do another ramp. 3. And for this I'm going to say a noise. Plug that in. And then inside here, so I would set this to red, this one to blue by Actually, I'm going to set it to green so that I can see it a little bit easier. See, it's really changing stuff up here. And then I can adjust the frequency of this. So. I'd probably go like something like that. A little bit, even then. Something a bit like that. And you can see it's a static moving image, so we would do a time offset here. So we'd say channel float to vector, flow to vector, come on, flow to vector, plug that in here, plug that into here, and we do like a multiply constant. And we would make this very subtle too. So something like that. Yep. Okay. Hopefully that was helpful to some. You would then just increase the points. So let's go 1,000 for each. That's how I do like a swirling vortex setup inside of Houdini. I don't use the default ones that you're given because I like to have full control. Hopefully that was helpful to somebody. We shall see you next time. See ya.